Welcome, this is Jackson Green Quorum, and this is my Physics 2211 Lab 1 titled Constant Velocity. Let's get right into it. So the purpose of this lab is simple. We're testing the difference between physical motion and simulated motion using a tracking software and comparing it to the code. Pretty much what we're doing is we're comparing the physical world to the ideal world. So the experiment's simple. We set up an object to roll across a given distance. Then we use this software called Tracker to upload the video of said object, set the necessary axes and the time skips so that we can give new positions. And then we're going to use Tracker's data to write code in GlowScript, which is Python, to see which data produces a more linear outcome. Pretty much what we want is the most constant velocity of the two. So the setup's simple. Like I said, I chose a marker to roll across a yardstick right here. You can actually see my hand. The purple lines are the axes, and this red dots are the little positions that I selected across the little time skips to update my position. Now over here in the code area, this is the code that I wrote, and we're updating the velocity, and then we're updating the position each and every time. We're updating the delta t within this while loop, and right here you'll see that while t is less than 1.502 seconds, that's actually the amount of time that Tracker had. Like I said, I used Tracker's data to write this code. So the outcome was simple. Tracker gave us this line right here, a little bit of bump, a little bit of curve in each section. But the code gave us something that was completely linear, and right here I plotted both data points in Excel. The blue is the Tracker, the orange is the GlowScript. You'll see immediately that Tracker gave us a bit of a wonky curve, whereas GlowScript's Python code gave us something beautifully linear, meaning that the code has a more constant velocity than Tracker. The equations used are simple: the velocity update formula, the average velocity formula, and the position update formula. Essentially what I'm doing is calculating the new final velocity, plugging it into here, dividing by 2 to find the average velocity, and plugging the average velocity along with the delta t using for our timestamp for our new position. Possible sources of error, well, human error with Tracker. Like I said before, I was the one that selected the axes. I was the one that selected the position across the time skip. So that could have had something to do with it. I could have misclicked. I could have had something slightly off, which gave us such a curve in our linear graph. Physical error goes into it as well, though. We didn't account for maybe the table was leaning a certain way. Maybe I pushed a little too hard and I didn't select correctly. There's a lot of things that go into it. Friction is another big one of them. Friction will show up in real life, but in the video that we uploaded to Tracker, when I selected the positions, it could have already been showing up. So a little what if the axes were changed from positive x to negative x, what would happen? Well, essentially up here where you see this line going to the top right, it would actually be going to the bottom right, something along those lines, because it would be going in the negative x direction, if that makes sense. And what does it mean when I set my net force equal to 0? And is it possible for me to say how many pushes and pulls are being added together? Yeah, it is. In this case, the marker is simply traveling along the x-axis. So all that's happening is the force of gravity going up, or going down, sorry, then the normal force of the table pushing against it, my hand pushing against the marker, and then the friction force pushing against the marker's motion. And yeah, so the concluding ideas is that the simulated versus the real life are two completely different things. We see this when we compare the graphs. Obviously, real life constant velocity is going to be a lot harder to achieve compared to the simulated GlowScript code, and understanding friction and other forces such as the friction force, kinetic friction, and a lot of things like that go into play here. So this has been my Lab 1, Constant Velocity. Thank you. Have a wonderful day.